Good morning students, God bless you. Welcome to Business Maths class 12th standard. In this class we are going to see about the 6th chapter, random variable and mathematical expectation. Okay, the 6th chapter. Especially in this class we are going to see about the random variable. What is the random variable? A random variable is a real value function defined on the sample space S in the interval minus infinity comma plus infinity. Only defined on this interval in the random variable. It is a real value function. Okay. And the random variable classified into two types. The first one is the discrete random variable. The second is the continuous random variable. Okay. The discrete random variable. Okay. The definition of discrete random variable is exists a random variable which can assume finite number of possible values. It's called a discrete random variable. Okay. Here the probability mass function PMF means probability mass function condition is P of xi greater than or equal to 0 for all I. And every I is a probability value is greater than or equal to 0 and more than 0 values. Then the second condition, summation I is equal to 1 to infinity, P of xi equal to 1. The sum of the probability is equal to 1. These two are condition of probability mass function. Okay. Then the cumulative distribution function define fx of x equal to P of x less than or equal to small x for all x belongs to R. It's a real value function. Okay. So the fx of x equal to P of x less than or equal to x. This is the cumulative distribution function. That is fx of x equal to summation x less than or equal to x P of xi. The sum of the probability is equal to the f of x. Okay. I understood the discrete random variable. Then the second one, continuous random variable. Continuous random variable definition is x is a random variable which takes on any value of the interval is called a continuous random variable. Probability density function f of x greater than or equal to 0. The continuous random variable is a f of x. The discrete random variable is a p of x. Okay. The f of x is greater than or equal to 0 for all x. Then the second condition, probability density function, integral minus infinity to plus infinity, f of x into dx equal to 1. Okay. The total integral value is equal to 1. Here the sum of the values are equal to 1. Okay. Then the cumulative distribution function fx of x equal to P of x less than or equal to x. The same. And the formula is here the P of x less than or equal to x equal to integral minus infinity to x f of t into dt. The x lies between minus infinity to plus infinity. Okay. Then some more f of minus infinity value is equal to 0. Capital F of minus infinity is equal to 0. Capital F of plus infinity equal to 1. Okay. Then the f dash of x, capital F dash of x equal to f of x, small f of x. Okay. Then P of a less than or equal to x less than or equal to b equal to f of b minus f of a. These three are very important now. Okay. Before start, read all the formulas very well. Okay. Okay, dear student. Exercise 6.1. First question. Construct cumulative distribution function for the given probability distribution. The probability distribution is given. Okay. Construct the cumulative distribution function. Okay, the solution. What is the formula for cumulative distribution function? We know that capital X of x equal to P of x less than or equal to x. Here for all x belongs to R. This is the cumulative distribution function formula. So one by one we substitute the x value in P of x. Okay. The P of x less than or equal to, first substitute the 0 which is equal to P of x less than or equal to 0 equal to 0 and below 0. Consider the table. Below zeros are not be given, so equal to 0. So P of x equal to 0. So this is one of problem. P of x is equal to 0 means P of x is equal to 0 value is 0.3. That's all. Then P of x less than or equal to 1 is equal to. So now P of x less than or equal to 1. Okay, equal to 1 and below 1. The below 1 is 0 also. So P of x is equal to 0 plus P of x is equal to 1. Okay, this is the meaning of P of x less than or equal to 1. 1 and below 1 values. Okay, which is equal to P of x is equal to 0 value is 0.3 plus P of x is equal to 1 value is 0.2, which is equal to the sum of the values 0.5. Okay, then P of x less than or equal to 2. Okay, this can be right. P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2, because the x less than or equal to 2. Equal to 2 and below 2 values. Below 2 are x is equal to 0, 1 and this is equal to 2. Okay, then sum of the values. P of x is equal to 0 is 0.3, 1 value is 0.2 and 2 value is 0.4. 0.3 plus 0.2 plus 0.4, which is equal. The sum of the value 3 plus 2, 5, 5 plus 4 and 0.9. Then consider the third value. P of x less than or equal to 3 is equal to or equal to 3 and below 3 values. Okay. P of x is equal to 0 plus P of x is equal to 1 plus P of x is equal to 2 plus P of x is equal to 3. Okay, which is equal to P of x is equal to 0 value is 0.3 plus 1 value is 0.2 plus 2 value is 0.4 plus 3 value is 0.1, which is equal to 3 plus 2 5, 5 plus 4 9, 9 plus 1 10, 0 carry 1, then 1.0 is equal to 1. P of x less than or equal to 3. Okay, so this is the cumulative distribution function. Okay, the cumulative distribution function. Therefore, the cumulative distribution function is P of x less than or equal to 0 equal to 0.3 and P of x less than or equal to 1 equal to 0.5 and P of x less than or equal to 2 equal to 0.9 and P of x less than or equal to 3 equal to 1. Okay, that's all the answer of first question. This is a formula for cumulative distribution function. Fx of x equal to b of x less than or equal to x. Understood the first question? Okay, next second question. Let x be a discrete random variable with the following probability mass function p of x. The probability mass function is given. Find and float the cumulative distribution function of x. Okay, the solution. The same manner, I also want to find the cumulative distribution function. Okay, the solution. First, I can write the probability mass function p of x. So the x values all are 3, 5, 8, and 10. The corresponding probability mass functions are 0.3, 0.2, 0.2, 0.2, or otherwise 0. That means below 3 values is 0 and above 10 values are 0. Okay. The solution. Okay. This is your given probability mass function. Okay. So find the cumulative distribution function. So formula fx of x. We know that fx of x equal to p of x less than or equal to x. Okay. First, the x value. First find the fx of 0 k, the 0 values is equal to p of x less than or equal to 0. So otherwise the below 3 values are 0, that represent the otherwise 0 k, which is equal to 0 k. Here x is less than 3, should be less than 3, below 3 values are 0, because here we want to plot the cumulative distribution function of x value also want to write. So x is less than 3, below 3 values are 0. And fx of 3 is equal to p of x less than or equal to 3. Okay, less than or equal to 3 means 3 and below 3 values. 3 only given, the below 3 values are 0. So the value is equal to 0.3. Okay, here the x value is 3 less than or equal to x less than 5, below 5 and r equal to 3. Okay, then fx of next 5 is equal to p of x less than or equal to 5. This is equal to less than or equal to 5 values are, below 5 values there, so 3 also taken. So p of values, this is 0.3 plus 0.2. They are directly taken right. Okay, the values on 0.3, 0.2 is equal to 0.5. Here x value is, so 5 less than or equal to x less than, so another value 8. So below 8 and r equal to 5. Okay, then fx of 8 is equal to p of x less than or equal to 8 is equal to up to 8 value, sum of the value 0.3 plus 0.2 plus the 8 value 0.3. Okay, which is equal to sum of the value 3 plus 2 5, 5 plus 3 8, 0.8. Here the x value is 8 less than or equal to x strictly less than 10. So next value is 10. Okay, then fx of 10 is equal to p of x less than or equal to 10, that is sum of all values 0.3 plus 0.2 plus 0.3 plus 0.2. Okay, so totally 3 plus 2 5, 5 plus 3 8, 8 plus 2 10, so 1.0. Okay, here the 10 is the last value, so no need to write a less than limit. So x is greater than or equal to, x is greater than or equal to 10. Okay, the formation is first start at slightly less than and finally finish greater than or equal to. Okay, this is only the condition of cumulative distribution function, don't forget. Okay, therefore question is find the cumulative distribution function. Cumulative distribution function is, okay, the fx of x. Fx of x equal to the p of x given, so take and write the fx of x. The first value is 0 if x is less than 3. Okay, then 0.3 if 3 less than x less than or equal to x less than 5. Then 0.5 if the condition is 5 less than or equal to x less than 8. Then 0.8 if 8 less than or equal to x less than 10. Finally, it's equal to 1 if x is greater than or equal to 10. That's all the answer of the second question. Okay, the third question, the discrete random variable x has the following probability function: p of x is equal to x, kx if x is equal to 2, 4, 6, k into x minus 2 if x is equal to 8, otherwise 0. Where k is a constant, show that k is equal to 1 by 18. Okay, so I want to show k is equal to 1 by 18. Okay, the solution. In this slide, want to find the value of k, use the formula summation I is equal to 1 to infinity p of xi equal to 1. Okay. The probability function is given. Let's write the probability function. Okay. The x value. X values are 2, 4, 6, 8, otherwise 0. Then p of x is equal to x. Okay. So now replacing x value k into x. So x is 2. So 2k. When x is equal to 2 means p of x is equal to 2k. Then 4k. 4 into k. Then 6 is a 6k. And x is equal to 8 means 8 minus 2 is 6. So 6k. So probability mass function now we get. Okay. Then where k is a constant, so that the value. We know that summation I is equal to 1 to infinity p of xi is equal to 1. This is your formula. Okay. So apply here sum of all the probability equal to 1. This is the probability of value. Then sum of all the values equal to 1. So 2k plus 4k plus 6k plus 6k equal to 1. Then sum of all the value 2 plus 4 6, 6 plus 6 12, 12 plus 6 18. So totally 18k equal to 1. So k is equal to 1 by 18. So hence prove the value. Okay, have you understood? Okay, the fifth question. 2 coins are tossed simultaneously. Getting a head is termed as success. Find the probability distribution of the number of successes. Find the probability of distribution. Probability distribution. Okay. The solution: when 2 coins are tossed, the sample space S is equal to, so already know what are the outcomes: head, 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 trial, trial, head, and trial, trial. These are the outcomes of when 2 coins are tossed. Okay, here n of s, total number of outcome is 1, 2, 3, 4. N of s is equal to 4. Okay, since getting a it is termed as a success. Therefore, the value of x are x denoted the heads. Here 2 heads. So 2, the 1 head. Here also 1 head. Here no head. Okay. So only consider the head values. Okay. Then the p of x is equal to 2 equal to p of x is equal to 2. That means the denominator is total number of outcomes. What is the total number of outcomes? Is 4. Number of favorable outcomes. 2 heads appear. Here gets 2 heads is only one term. Okay. So 1. Okay. Then p of x is equal to 1. So only one head. Only one head has 2 terms. Okay. So 2. The total number of outcome is 4. Okay. Then p of x is equal to 0. This is already find out. P of x is equal to 1. Then 0. P of x is equal to 0. So no heads appear. Chances totally 4 chance. So no head appear is only one chance. So 1. Therefore, the probability mass function is x is the values of this. So 0, 1, 2. Okay. Then p of x is equal to x. the p of x is equal to x values is 0. If you put, we get 1 by 4. Then x value is 1, we get 2 by 4. So using the calculation, 1 2s are 2, 2 2s are 4. Okay. So this is 1 by 2. Then 2 heads appear chances 1 by 4. That's all. This is your probability distribution. Okay, this is the answer of this question. Have you understood? Okay, dear student, today's homework page numbers 126, 127 and 132. Example 6.1, 6.2 and 6.3. And exercise 6.1, question number 4. Okay. So that's all today homework. Do it well. Thank you. God bless you.